Hello, everyone. I hope you all had a nice Thanksgiving if you celebrated. I owe you another demo. So here we are. I have some cool new features to show, and I'll give the general status details as usual. I'm going to comment real quick that I have had some issues with my screen share. Depending on which software I use to record, I either have issues with sound or issues with video. I'm currently using this option that produces better sound, but you may see some choppiness in the animation of the gears as they rotate. This is not the software itself being choppy, it's just the screen share. Just wanted you to be aware of that. And for what I'm doing today, I don't think it'll be as important that the video is super smooth. So okay, let's get into it. All right, so the first new feature I want to show is that you can actually do an import from a DXF file. Up here where you would normally do the editing and the modification, which you can still do, you can go to this drop down here on more input methods, and under from DXF, you can click the import button, and you can grab a file that you've set up. I have just a nice ellipse here. I do need to zoom out a bit to actually find it. Eventually it'll auto zoom, but for now you have to zoom manually. And you can, if you want to, actually do transformations, shift the position of the ellipse if you wish. You can scale and rotate it if you want, but it shouldn't matter that much. And when you're done positioning it, you say trace, and the shape adapts to fit the curves that you imported. And from there, you can proceed forward. You can add your mating gears in the next step. Go forward here and say Gearify. And voila, just like that, we went from a DXF file to an actual gear design. You'd have to fuss with the parameters of this a little bit to get rid of some of those self-collisions, but the essential details are there. So let me go back and let me demonstrate a different design. So I'm going to choose bilateral symmetry with a radial symmetry of 2. As I demonstrated in some of the earlier videos, you have this region that I call the defining lobe, which is where you do your actual edits, and every other area just copies based on the symmetry. And when you do a DXF import, likewise, that region is the only region that actually matters. So here I have a file called rounded corners, and you can see it's not a complete closed curve, it's just this corner. In fact, I'll even shift it down a little bit, and I'll say trace, and it read the shape of the curve in just that region. And now I've derived a shape from that curve pretty seamlessly. Look at that. Look how beautiful that is. Make a nice little matching shape and gearify this guy. Wow. I can probably use fewer teeth on that one. 12 teeth. Very nice. It's fun to watch the contact. It's probably a little choppy on the video share, but hopefully you can appreciate it somewhat. Okay, so let me show you an example of when the DXF spline trace mechanism doesn't work as well. All right, so bilateral symmetry off, radial symmetry 1, in design, input methods, import, go to ellipse, arc, and spline. Zoom out to find it. Okay, I'm going to trace this design. So the two curves you see here, one is the source DXF shape and the other is the spline curve that's traced out, which produces the pitch curve. And you can see pretty clearly there are some discrepancies here, some differences between the two curves. Now I can improve that by increasing the number of sample points, but even if I do, the discrepancies never totally go away. So even with 120 points here, you see a noticeable discrepancy here. This is because this is not yet the fully featured DXF importer capability, which I have planned. The fully featured one will very accurately, in fact perfectly, represent the input shapes, whether they are arcs, lines, splines, ellipse arcs, etc. But it will take a bit longer to implement that fully featured importer. So in the interest of getting a good beta release out relatively soon, I opted to put this in. And I actually think it's pretty effective if you're willing to put up with a few discrepancies here and there. Okay, and now briefly, I'll just show you also that you have the option of the graphing calculator mode, which is a pretty classic input method for Gearify. Zoom in there, I'm going to click graph. The principles are very much the same as the DXF import. First, it gives you your shape, which you can shift and move around, and then you just click trace when you're done. Now, an important thing to note is that it cannot yet automatically detect what the symmetry is. I happen to put in one with symmetry 3, but Gearify doesn't know that yet. I haven't made it smart enough to detect that. So what you have to do is anticipate what symmetry you intend to put in. In fact, for this one, I could even say bilateral symmetry, because that's what it will be. And I can type in my formula, 3 plus cosine of 3 times t. Graph, you can see it there. Notice how it only traced out the defining lobe region. And I say trace, and there. Now you can see the design, and all the rules are the same. Let me kind of reduce that concavity a little bit more, make it a little bit more rounded. There we are, very nice. And I'm going to say finalize, and just make a nice matching gear for this guy. Nice, all right. So that was the polar graphing calculator input method, which is, pretty much behaves the same as the DXF import. So now let me show you what I can actually do from this point, because once you've made a gear, eventually you want to get it out of the software, of course. So I have here some options to select a DXF version, currently supported up to 2018. And I can say export, and I'll just say out gear, save. And if I open that file, I'm just going to open up LibreCAD so you can see. File open. There we are. You see you actually have your imported design. So what you can actually do is you can show and hide the various gears. Accidentally selected that. And it'll export basically more or less what you see is what you get. I will eventually include the option to include the pitch curve itself in the export. For now, it's just doing the tooth outlines. All right, I want to talk a little bit more about tooth parameterizations. First of all, I apologize last month. This dropdown was not showing up on the screen share software I was using. I don't know why. Part of the reason I'm switching this time. Apologies for that. But these are all the various parameters that you can edit. I will be eventually posting more details about how all of them work. But I thought I'd go into just one of them today, and this is the min gap distance. So I'll show you down here. I have a very rough diagram, but this is the general idea. So your tooth flanks will cross the pitch curve at one particular location, and that distance between the two flanks where they cross creates a certain distance, d. The peak distance, which I call w here, sometimes you don't want it to get too small or too pointy. So this min gap distance peak proportion for the top of the tooth controls how wide that peak distance is. It actually controls the minimum distance, because in some cases, the distance will already be wider than the value that this determines. Well, let me show you real quick. Particularly in curved regions, you sometimes will see some very pointy areas, like this guy, for instance. So what I can do is I have this parameter set, and actually go and increase the value. Sample is going up to, say, I don't know, maybe make it 0.4, for instance, and say Gearify. And you see it significantly blunts those tooth tips. But I only modified the variation curve in this region, so it'll only affect teeth that are local to that region. But you see it drops off over here. But if I wanted to, I could modify this end of the curve as well. I can say add a control point, increase it to around 0.4, say Gearify, and it blunts the teeth on this side as well. Another feature that I added since last month, some of you may have noticed, last month I could only edit these variation curves in the first region of the gear. So here I have 3 repetitions of the same region because it's a symmetry 3. In this case, 2 repetitions because it's a symmetry 2. Before you could only do it in the first lobe, but now you see anywhere you modify it, you can actually interact with it on any side, and it will just modify and handle the symmetric copying and duplication just fine, but you don't need to manipulate it in any particular region. You can just do it wherever you want. So it makes a world of difference from a user experience point of view. So that was very, very much needed. Okay, so where does that put us? As far as features are concerned, all the essential features that are necessary for a beta release are now in there. You see, you can do import, export, plenty of editability and customization options and so on. So I need to take a little bit of time just to do some light polish, maybe a couple weeks or so, and then I am on to deployment, which, you know, there will be a bit to do there, as I've mentioned, but won't be long now. Really, really getting close. In fact, the first alpha release has actually been given out to my father to begin testing and evaluating. Maybe a pre-alpha release, you might call that. But yeah, I mean, we're very close, and I just need people to hang in there with me, and bear with me, be patient, and it really won't be long now. So thank you for following these videos and keeping up to date with it, and I'm really excited to deliver some cool software to you soon. So until next month.